Welcome to your channel, that is Civil Engineering Choice. And we know that already we have started the series to calculate the shear force and bending moment diagram of various types of beam. So already we have covered few numericals on the simply supported beam carrying a different load for the calculation of shear force and bending moment diagram. And now from today we are starting the new subject, videos on new subject, that is design of reinforced concrete structure. So design of reinforced concrete structure is most important subjects for the structural engineer, and MPSC point of view also this subject is most important. So let's start with the content. So these are the how many structures are available for the design point of view. Then we will discuss about the who is a structural engineer and what is the role of that structural engineer, that we will discuss. Then basic requirement of design, general introductions regarding the reinforced concrete structure or the RCC structure, we can say. Loads on the structures, which type of loads generally coming on the RCC structure. So here whatever load we are going to cover, that load is totally based on RCC structure, because we have started our series for the reinforced concrete structure. So we will discuss everything as per the reinforced concrete structure. Then we will discuss introductions to various design philosophies for the RCC structures, like working stress method, ultimate load method, and the limit state method. So basically we are using these two methods, working stress method and the limit state method. So few structures are there that we are designing for by using the working stress method, like water tank, and few elements of the few structures are there, for that we are using the limit state method. So what is working stress method, what is limit state method, everything we will discuss it. But instead of that working stress method, we will mostly focus on the limit state method. So if you go with the limit state method, so in limit state method we will going to discuss about the limit state of collapse, limit state of serviceability, and limit state of durability. So collapse, serviceability, and durability, these are the main contents in the limit state that we will going to discuss in upcoming videos. Then the next is we will discuss about the characteristic strength, then characteristics load, partial safety factors for material strength and load, okay, material strength and load. Then provisions in Indian standard code practices, okay, means what provisions are given in the Indian standard or the IS code for the design of RCC structure, that we will going to discuss. And then we will discuss about the study of structural properties of the concrete which are required for the design of reinforced concrete structure. Okay, so these are the contents that we will going to cover in upcoming videos. So let's start with the types of structure. So if you see, there are so many types of structures are available for the design point of view, but which type of structures we have to consider for the design, that is totally depend on the requirement of, we can say, the client, or requirement whatever load is coming on the buildings, and in short we can say the requirement of that particular building. So on that basis we can think about the type of structure for the design point of view. But if you see how many structures are available for the design point of view, in that the first is the reinforced concrete structure. Just we have started the series for the reinforced concrete structure. So reinforced concrete structure is there. Then we can see the steel structures are there, okay, timber or wood structures are there, aluminum structures are there, glass structure, stone structure, masonry structure, composite structure, and some other structures also there. So basically if you see the types of structure, the types of structure is totally depend on the types of material that we are using for the particular structure. Okay, let's say suppose we are using the reinforced, means steel as well as the concrete, that structure is called as a reinforced concrete structure. When we are using the steel only, so that structure is called as a steel structure. When we are using the timber or the wood, that structure is called as a timber or timber or wooden structure. If we are using aluminum, glass, so it means whatever type of structures we have given over here, that types of structure is totally based on the types of material that we are using for the particular structure. Okay, so these are the types. And if you go with the first type, so the first is what? Reinforced concrete structure. So what is meant by reinforced concrete structure? The structure made using the concrete reinforced with the steel concrete structure with the steel bars to handle the tensile and compressive force. Okay, means we are using the concrete as well as the steel bars in the structure. That particular structure is called as a reinforced concrete structure, and generally that structure we use to resist the tensile and compressive forces. Okay, so what purpose we are using the concrete and why we are using the steel rebars, that we will discuss in deeply. Okay, but now here we can just understand the reinforced concrete structure means what? We are using concrete as well as the reinforcement or the bars, steel bars, to resist the tensile and compressive forces. Okay, then the next one is what? Then next one is the steel structure. But before that, here we can see this, that RCC structure we can use for the residential building, bridges, dam, high-rise buildings, and the water tank. Okay, so these are the structures that we in that we can use the reinforced concrete structure. Then another structure is there, that is steel structure. So structures are primarily made by the steel, means the structure is basically made by the steel. That structure is called as a steel structure and known their strength, flexibility and easy construction. So steel structure is having the more strength, it's very flexible and easy to construction, okay, because we are using only steel to construct that particular structure. So that structure is called as a steel structure, okay. Then these are the some examples, okay, in which we are using only the steel for the construction, like industrial building or the industrial shed, we can say, warehouses, bridges, where the truss and suspension bridges we are using. So suspension bridges, or we can say the truss is specially or is fully made by the steel, okay. Transmission towers, stadiums and the large span roof, if we require the large span, so in that case also we have to go with the steel member. So that particular structure is called as a steel structure, okay. So once we consider this steel structure, the next one is the wood structure, okay. Again, as we discussed, when we are going with the wood structure, so main function or the main material in that structure is only the wood. So when we are using the timber and the engineer wood, that structure is called as a timber or wooden structure, and this structure is commonly used in low rise building, and the reason where we are using where we will get the maximum quantity of wood, only in that case we can use the wooden structure, okay. Then wooden structure, the examples of wooden structure is residential houses, cabins and cottages, wooden bridges, shade, historical and heritage structures, okay. These are the types of structures that we can build in the timbers, okay. So these are the most important structures any. Okay, so next one is who is a structural engineer. A structural engineer is a civil engineer who specializes in a design and analysis. Basically, structural engineer is a one of the civil engineer, and whose specialization means structure civil engineer having the specialization in the designing and the analysis of structures to ensure that. So the structural engineer should ensure that the safety of that building stable, capable of withstanding the various loads, okay. Means the structural engineers should be analyze the design of the structure such that the structure should be safe, stable, and that structure should be capable to withstand with the various loads, okay, like dead load, live load, wind load and the seismic load. So that the structure should be stable by considering all these loads. The structural engineers work on the projects such as building bridges, towers, dams and even special structures like stadiums, okay. Means where we require the critical analysis and design of any element or any member, so that can be done by the structural engineer, and the structural engineer is nothing but the civil engineer, but that civil engineer or the civil engineer should have the specialization in the design and analysis engineer, okay. Then the key responsibilities, okay. So what is the responsibilities of the structural engineer? The first is the structural design and the analysis, means whatever structures the structure is there, so that structure should be analyzed and designed properly. That is the main role of the structural engineer or the main responsibility of the structural engineer, okay. Design structure, develop design for beam, column, slab, foundation and the other structural elements, means whatever structures we are designing, that structure whatever elements are there in that particular structure, so every element design are comes under the structural engineer. Like beam, if you consider the RCC building, in RCC building we can see the beam, column, slab, foundation and any other critical elements or the critical structural components are there. So design of that critical components or design of that every components or element is done by the structural engineer. Use codes, so whatever design procedure is there, that design procedure is totally as per the codal provision, okay. So in India generally we are using Indian standard like IS code, okay. So in every country or every country have their own code for the design of the particular elements, okay. Now these RCC means reinforced concrete structures, we are dealing with the or we are going to design all the elements as per the Indian standard, so we will use the Indian standard, the IS code for the design of that structure, okay. So what codes are available? So here I have mentioned only two codes like IS 456 and 800. So IS 456 generally we use for the RCC means reinforcement concrete, and 800 we use for the steel structure, okay. All other structure or other codes are also there, but that codes generally we use as per the structure, means water tank having the different code, then retaining wall having the different code, every element or every structure have their own code for the design purpose, okay. But these are the main codes that we are using for the RCC and steel, okay. The software tools, so which softwares are available for the analysis and design, so the structural engineer can take help of that software to analyze and design of particular structure. So StatPro, ETAB, CAD is generally used for the drafting, okay. Then SAP 2000, So STAD and ETAP, these are the most important software generally structural engineer are using. The generally ETAP is used for the RCC structure analysis and STAD is used for the steel structure analysis and design. Okay, all other softwares are also there, because ETAP, after the analysis in ETAP, then we are using RCDC for the design, and then SAFE. Okay, so RCDC is generally used to design the all the elements, structural elements like beam, slab, and foundation. And the SAFE software is generally used for the foundation, specifically used for the foundation design. So all types of foundation we can design in the SAFE software. Okay, and then the next responsibility of the structural engineer is what? To calculate the load calculation. Whatever structure we are designing, or the structural engineer is designing, the first thing is what? The structural engineer should calculate the total load properly, calculate the total load coming on your structure. Okay, so identify and calculate the different loads on the structure acting on the structure, like dead load, light load, wind load, earthquake load. So he means structural engineer should identify which type of loads are coming on the structure, and he should calculate that load properly for the analysis. Okay, this is a second responsibility of the structural engineer. Third one is the material selection. Okay, once you calculate the loads and once you decide the purpose of that building, then next term is what? You have to choose the material from the concrete, steel, timber, or the composites. Means which type of material we can use for the particular structure, so we can make that structure is economical and stable. So these things are most important, stable as well as the economical. So by considering the loads and everything, the structural engineer should decide the material, which type of material he can use for the particular structure, and it is totally based on the which type of loadings are coming on the structure as well as the purpose of that structure. Okay, then selection of material. The next is safety and risk management. Yes, it is the most important parameter. So when the structural engineer is designing any structure, okay, so he should be design that structure such that it should be reduce the potential hazard like earthquake and high risk, high wind. Okay, if any lateral load is coming on the member, or any heavy load is coming on the member or the structure, the structural engineer should take care of that structure, take care of that load. So whatever load is coming on that particular member, that can be resisted by the element. Okay, so safety and the risk management is also important. Collaboration with the other teams. Yes, definitely this is also one of the important role of structural engineer, because structural engineer is, we can say, it is the main engineer for every types of building. So uh, he should collaborate with the architect. Okay, he should collaborate with the architect, then construction manager, okay, and the site engineer. So he has to continuously communicate with the all other engineers or all other members which are working on that particular project on the site. Okay, inspection and maintenance. Yes, inspection and maintenance is also one of the important responsibility of structural engineer. Means inspect the existing structures for the safety and recommend the maintenance or the repair when necessary. Okay, all these points. Okay, then tools and technology you have to learn. Means if you are the structural engineer, so you have to learn some software, or you have some knowledge about some softwares, because if any high-rise building is there, or if any building is there, so first we have to analyze it, and then we have to go for the design. And for the analysis and design, to minimize our time, we have to use the some tools, or we can say the some softwares, and these are the some softwares that are most important for the structural engineer, like AutoCAD. So generally AutoCAD is used for the drafting of structural drawings. Okay, so if you have the sufficient knowledge for the AutoCAD to draw the structural drawings, so that is good for the structural engineer. So, or we can say the structural engineer should take the knowledge of AutoCAD. Then StatPro and ETAP, as we discussed, StatPro generally used for the analysis and design of industrial shell, and the ETAP we use for the analysis of RCC structure. Okay, then RCDC, the RCDC software we can use to design the RCC member, like beam, slab, column, foundation, etc. SAFE software is also there. That SAFE software we can use to design the foundation. Okay, mainly foundation we can design in SAFE software. Then some finite element analysis, means some softwares are there in that we can do the finite elements like ANSYS. Okay, so this software you can use. Suppose you want to do the critical analysis of any particular element, or the analysis or the joint analysis, so you can use that ANSYS software for the analysis. Then BIM, yes, it is most famous now, building informations and modeling. So in building information modeling, generally total engineers are involved, like structural engineer, then construction management engineer, water resource engineer, or environmental engineer. Or we can say that all engineers are comes in the building information modeling format, and that knowledge also structural engineer should have for the design and analysis. Okay, then the next one is career opportunities. So where the structural engineer can be work. Okay, the structural engineer, you can work in various fields, including like building construction, infrastructure project, consulting firm. You can open your consulting firm for the design of all types of structures, seismic design and the retrofitting. You can do the retrofitting recommendations for the maintenance and everything. Research and development also you can work. Government organization and PUC means public sector undertaking. So these are the few what we can say the fields that I have mentioned over here in which the structural engineer can work. Okay, the basic requirement of the design. The basic requirement of the design is what the structure should be safe. The structure should have the sufficient serviceability. Means what the function of the structures are adequately ensured against the forcible actions acting on the structures. Means if any deflection is there of or if any what we can say bending is there, so that structure can be stable. So serviceability is also important part. The next one is durability. The structure should be durable, means long life. The structure should uh, uh, sustain the load in a long life period. Then economy, the structure should be economy. Whatever structure he is designing, okay, that should be economy. So these are the basic requirement as a structural engineer or the design point of view. Then now comes to our main topic, that is general introduction of RCC structure. Okay, in general introductions means we are just focusing on the RCC means reinforced concrete structure. Okay, reinforced cement concrete structure ऐसे भी कुछ बोलते हैं लोग. Okay, so reinforced cement concrete. So we will discuss about the reinforced concrete structure from from this point. So the reinforced cement concrete structure RCC is a composite material that combines concrete with the reinforcement bars, usually steel, to enhance its strength and the durability. Okay, so in RCC structure we are using concrete as well as the reinforcing bar. We are using concrete as well as the reinforcing bar to enhance the strength and the durability of that particular structure. Okay, so in simple language you can use the RCC is what? It is the combination of concrete and reinforcement bar. So concrete by itself is strong in compression but weak in tension. We know that if you go with the concrete, so concrete is a weak in tension and the strong in compression. Okay, so tensile stresses. Okay, to overcome this weakness means we know that concrete strong in compression and weak in tension. So whatever weakness is there means tension. Tension is a weakness of the we can say the concrete. Okay, so to overcome that weakness, the steel reinforcement or we can say the rebar is embedded within the concrete to reduce the tensile forces. Okay, the making RCC suitable for the structural element that experience both the compression and tension. Okay, means if you consider any structural element, in that particular structural element there will be compression as well as tension. So the concrete can resist the compression, but for the tension resistance we are using steel. Okay, this is the main purpose of our RCC structure. Then advantages of RCC: first, strength. Okay, means RCC have very good strength in tension as well as the compression, because steel we are using for to steel we are using to resist the tensile forces, and the compression we are using for the concrete we are using for the compression. Okay, so strength is good. Durability: the RCC structures are durable if designed and laid properly. Means if we have or the structural engineer have designed that RCC structure properly, so the durability of that structure is very good, and they can last up to the 50 years. Means we can consider that RCC structure up to the 50 years. Then moldability means we can mold that structure, RCC structure, in any shape. Okay, because remember, durability, yes, the structure ductility, sorry, the ductility, the steel reinforced impact the ductility to the RCC structure. The ductility is very good because we are using the steel reinforcement. Economy, yes, definitely the RCC structure is cheaper as compared to the steel and precise concrete. Yes, this is also one of the structure, precise concrete structure generally we are using for the bridges to prepare the girders of the bridges. So precise concrete structure is also there. But if you compare the steel and precise concrete structure, the RCC is very economical as compared to these two structures. There is an overall economy by using the RCC because its maintenance cost is very low. Okay, the main purpose of the RCC structure is what? The maintenance cost of the RCC structure is very low as compared to the steel and the precise concrete structure. Okay, then another advantage is transportation, easy to transport. Okay, then fire resistance, the RCC structure is fire resistant structure. Then permeability, its permeability is also good. Okay, seismic resistance, yeah, definitely every structure is a seismic resistance, but properly design of RCC structure can be resist the earthquake. Okay, means we have to design it properly to resist the earthquake load. So these are the advantages of the RCC structure. Then next, we will focus on the disadvantage of RCC structures. First, the RCC structures are heavier than the structures of other materials like steel, wood, and glass. Yes, definitely, we are using steel as well as the concrete, so we require the huge area, or we can say use quantity of concrete to resist the particular load as compared to the steel and wood and glass material. RCC need a lot of formwork, definitely centering and shuttering to be fixed, thus required lot of site space and the skill labor. Okay, when we are constructing any RCC building, so require we require to provide the formwork. Okay, and that formwork is required maximum space for the construction. Okay, or to hold the RCC members, and also the RCC structure required the skill labors when the settling and the formwork comes in picture. Then concrete takes times to attain its full strength, thus the RCC structure cannot be used immediately after the construction like steel structure. Okay, so basically what happened, the steel structure, when we build the steel structure, so immediately we can use that steel structure, but RCC structure or the concrete takes some time to set properly. We know that generally concrete take its full strength after 28 days curing. Okay, so the structure is required, means RCC structure we cannot be used immediately as compared to the steel structure. Okay, then these are the some disadvantages. Okay, then the loads on the structure, how many loads are coming on the structure? Okay, the first, dead load. These are the permanent load that we know that, and these are the static loads. Okay, due to the weight of the structure and any fixed elements, means if any fixed elements is there and whatever weight of structure is there, that totally comes under the dead load, and dead load is a permanent load. The second one is a live load, but before that we will see examples. Okay, so weight of beam, column, slab and walls, these are comes under the dead load. Weight of finishes means we are providing tiles, plasters, or any concreting or any waterproofing material uh, on the floor. So that finishes also comes under the dead load. Then fixed installations like HVAC systems and the plumbing. Okay, so whatever HVAC systems we are using, plumbing system we are using, so that loads also comes under the dead load. So these are the loads, and if you want to calculate the dead load, so self weight of the member, we are talking about the self weight of the member. So we can use dead load equals to volume into density of material. Okay, and for RCC generally we are using 25 kilonewton per meter cube density. But yes, for calculation of load, we can use this formula volume into density of material. Means suppose we are using wood. Okay, so we have to use the density of wood to calculate the self weight or to calculate the dead load. Okay, so this is a what we can say the common formula that you can use to calculate the dead load. Okay, the next one is the live load, or some structural engineers are called it a imposed load. So there are transit loads due to the occupancy and the uses of the structure. So it may be changed because live load can be changed as per the purpose of our building. So human occupancies like office spaces, residential building. So whatever live load is there, the live load is totally depend on the building, means what purpose we are using that building. Okay, means if any residential building is there, so live load is less as compared to the offices, or if any commercial building is there, so in that case your live load will be increased. And in the codal provision they have given the live load as per the purpose of our building and as per the purpose of floor. Okay, furniture, movable partitions and the equipments also comes under the live load. Vehicles and the vehicles in the parking structures also comes under the live load. Okay, and the standards are generally we are using IS 875 part 2 to calculate or to consider the live load on the structure. Okay, wind loads. Okay, also these are the lateral loads caused by the wind pressure acting on the structure. Okay, so factor affecting wind load, wind speed and the direction, building height and shape. Okay, terrain and location category. Okay, so these are the factors that can be affect on the wind load. But yes, definitely if any high rise building is there, so we have to design that building for the wind load. Okay, and we can say wind load is a lateral load. The calculations we can use IS 875 part 3 to calculate the wind load. Okay, seismic load is also most important. Seismic load is also one of the lateral load. Okay, the load generated due to the earthquake induced ground motion. The RCC structure must be designed to withstand a seismic forces to prevent the collapse. Okay, so we are using seismic load also, or we have to consider the seismic loads also. Some factors are there which are affect on the seismic load, like seismic zone classifications, where your building is stand. So as per that zone we have to consider the zone factor. Soil type is also important, whether your soil is soft, medium or hard. As per that conditions you have to decide the seismic parameters. Then importance factor of the building, response reduction factor, ductility, and the irregularities. So these are the some factors that are affecting on the seismic loads, or we can say we have to consider these factors to calculate the seismic load. Okay, so the code is 1893 part 1 is there to calculate the seismic load. So we will see one by one everything in upcoming session. And these are the some loads that we need to keep in mind for the design of any structure, like thermal load, snow load, impact load, foundation loads, is bearing pressure, everything. Okay, and yes, the next one is the load combination. Actually, load combination is not comes under the load, but actually when we are designing any building by using two or more loads, so in that case we have to use the load combination. Okay, so load combination is most important for the design of for the analysis, we can say first, and then we have to use that load combination for the design purpose, and that load combination we will get from the IS 875 part 5. Okay, these are the typical load combinations. Generally we can use like dead load plus live load, dead load plus wind load, dead load plus earthquake load, dead load plus live load plus earthquake load. Okay, so these are the typical load combinations, but yes, we have to confirm that load combinations as per the codal provision before analysis. Means when we are using any tools like ETAB, RCDC for the analysis, sorry, ETAB and StatPro for the analysis. So in the analysis or before analyze that structures, we have to provide the load combinations as per the codal provision like IS 875 part 5. Okay, then the next one is the design philosophies. So in design philosophies means what? How many methods are available for the design of structure? Okay, how many methods are available for the design of structures? So basically we have three types of structure, three methods. Okay, basically we have three methods like working stress method. Okay, that working stress method is also called as a allowable stress method, then ultimate load method, and the limit state method. Okay, these are the methods which are available for the design of structure, and every method have their own rule or own assumptions for the design of any element. Okay, so short form also we have mentioned over there, that is working stress method, that is called as WSM. Okay, or allowable stress design is ASD, ultimate load method ULM, and the limit state method is LSM. So basically we are using these two methods, LSM and WSM. Okay, so we will see uh, what is meant by limit state method, what is meant by working stress method, what is meant by ultimate load method in the next video. Okay, thank you so much for watching this video, and if you are really like that videos, and if you are really getting some knowledge from this video, so please like and subscribe my channel. And as I'm discussing in every video, we are planning to upload all the videos on all the subjects which are related to structural engineer, like engineering mechanics, strength of material, structural analysis, the structural design of RCC member, this design of reinforced concrete structure, design of steel structure, design of precise structure. Okay, and again we are planning to upload some videos which are related to field point of view. Okay, so I request everyone, please like and subscribe my channel, and please click on the bell icon so you will get the notification of my videos. Okay, thank you so much.